Hi, Peter here. In this video we'll look at simple techniques for debugging. None of us are perfect, and so we'll often make mistakes when we write programs. It's therefore important to develop skills for effective testing and debugging. Before looking at our example debugging problem, I will spend a few minutes on some other more high-level issues. The worst thing I can do as a programmer when confronted with a complex problem is to just bash away at the code and leave testing to the end. This is a bad idea for two reasons. First, it's difficult for me to maintain a complete picture of the overall problem when trying to write code, and so I'm bound to make mistakes. Second, if I leave testing until the end and I find a bug, and there will be bugs, then where is the bug? It could be anywhere. On the other hand, if I take some time and try to break the large complex problem down into simple problems, then I have something that is more manageable. A good idea is to write down a description of what the solution of each small problem should look like, and also to write down some examples of what should happen. The description can turn into function comments, which is always a good idea. The examples are useful for two reasons. They can help me think about how to solve the problem, and particularly if you're the sort of person who solves problems via examples. And when I have what I think is a solution, I can use those examples to test my code. Now when I find a bug, it's in the piece of code I've just written. My debugging is then much more focused than if I had left testing until the end. Okay, now let's get on to our debugging problem. This is a function to calculate factorials using a while loop. Okay, so let's just try it. I've got an example here of what factorial should look like, so let's load it up and try it. So we load it, and okay, so let's try factorial 24. Oh dear, it gives me 0. Okay, so what's going on here? Well, one thing we could do is stare at the code and try to figure out what to do, and that often will help. But a good technique is to, particularly when dealing with loops, is to put in some print statements. And here we'll just print out the value of C, which looks important because it's giving us kind of a loop counter, if you like. And so we'll print C. And also result looks important because it's supposed to be building up the result of our computation. So let's add those two things in as a print statement and try that. So let's load that up again and try factorial 24 again. Okay, so here we're seeing that it prints out C is 1 and result is 0, but it only prints that out once, and then it prints out the final result of 0. So clearly we're only going through the body of this while loop once. Okay, now a common problem or a common thing that can happen when you get this situation is, as has happened here, we've got a return inside the body of the while loop. Now we didn't mean to do that, we made a mistake. We meant the return to be outside the while loop, so we need to de-indent the return statement. This is a very common problem, and indenting to the wrong level is a source of various kinds of problems in Python. Okay, so we seem to have got that right, so let's try again. We'll save that and try again. Okay. Whoa. Something funny's going on there. Oh, that's because we got factorial 24. Okay, but even so, I meant to put factorial 4 in, but we can see that we're now stepping through and we're doing it 23 times, but our result is always 0. So that seems a problem. We should be accumulating the products as we go. So what's going on here? Well, if we look carefully, we've initialized result to 0, and therefore any time we multiply 0 by a number we'll get 0. So that seems to be the mistake. So it looks like what we meant to do was put a 1 there for the result. So let's save that again and run it. And this time I'll do factorial 4 rather than 24. Okay, this is interesting. So what's happened here? Well, we haven't got the right answer yet. We've got 6 rather than 24. So we've got 1, 2 and 3 as the counters. And we seem to be building up something like what we mean to build up. But we only got to 3 and we should have got to 4. So clearly there's something wrong. We're not really going far enough in our loop. So if we look at our loop test has got C less than n, and we're missing out on the n itself. So we should go all the way up. So in the case when n is 4, we should go all the way up to and include 4. So the way to fix that is we just put an equals there. So this is now less than or equal to test. So let's save that again and load it and try factorial 4 again. Now we're happy. We see that as we step through the list, as we step through the loop, we get 1, 2, 3 and 4 for values of C, and then we get 1 and then 1, 2, 6. Now notice the result doesn't get to 24 when we do the print, but the final result is 24. Now why is that happening? Well, it's happening because we're printing the result before we do this update to result. If we'd moved the print statement to the end of the loop, we would have got a slightly different output. So sometimes it's good to put a print statement at the beginning of the loop, sometimes it's useful to put a print statement at the end of the loop, and sometimes it's useful to have a print both at the beginning and at the end. In this case, putting the print at the beginning was enough to solve all of the problems in this piece of code. Okay, well that's that for this particular example.